Good morning to all. Today we are going to discuss about graphical representation of collected data. So the first graphical representation is histogram. What is a histogram? Listen, histogram is a bar graph that shows the frequency of data within equal intervals. There is no space between the bars in a histogram. Listen, histogram is a bar graph. What do you mean by bar graph? Yes, bar graph is a graph of representation of collected data using separated rectangles. Okay, so at the same time histogram is a bar graph in such a manner that we are arranging these rectangles very close together. That is, there is no space between the bars or rectangles. Let's see this example. The table below shows the number of hours students watch TV in 1 week. Okay, make a histogram of the data. See the table. First column number of hours of TV and second column is frequency. Listen, the first column is class interval. So here the class intervals are 1 to 3, 4 to 6, 7 to 9. Okay, that means from 1 to 3 or in between 1 hour to 3 hour, 15 students watch TV. Okay. Then 4 to 6. So 17 students watch 4 hours to 6 hours. Okay. 4 hours to 6 hours. So we need to find or need to draw histogram for this table. Let's see how to draw the histogram of this collected data given. See, we need x-axis and y-axis. Listen, along x-axis we need to write hours, number of hours of TV, and along y-axis we need to write frequency. See the figure. See, in this manner we can arrange the rectangles. See, there is no gap between these rectangles. So we will see how to draw this histogram. You just go through the figure. This is histogram. In this manner we can represent the given data in the form of a closely arranged rectangles. You can see there is no gap between or there is no space between each rectangles. Let's see the difference between bar graph and histogram. See the first figure. See, in this figure we can see 5 rectangles and these rectangles are separated rectangles. There is a space between each of these 5 rectangles, isn't it? So bar means rectangles. Bars have equal space, and on the y-axis we have numbers and on x-axis we have data which can be anything. That is the method. See, in bar graph usually along y-axis we can represent only numbers. At the same time along x-axis whatever data given in the question that we have to mention. At the same time in the next picture, next graph, that is histogram, you can see that these bars or rectangles are fixed. Fixed means there is no space between each of these rectangles, isn't it? And another thing is that on x-axis and y-axis you can see the numbers are represented. Okay, numbers are represented and the data which is continuous and will always be a number along both x-axis and y-axis. So this is the difference between bar graph and histogram. So in this session we will discuss how to construct a bar graph and also how to construct a histogram. Let's see some examples. Before that, we need to identify the given data as in the form of continuous or not. Listen this table. See, this is a data of lifetime of a lamp. See, lifetime is given in hours and number of lamps, that is frequency. Data is given. See, you have to concentrate the class intervals. Class intervals means the first column. Okay, see the first column, lifetime, that is in the form of classes. You can see that classes are 300 to 400, 400 to 500, 500 to 600 and so on. Here we can see that upper limit of the first class interval is 300 to 400. So here upper limit is 400. So the same upper limit 400 is the lower limit of the next class, isn't it? 400 to 500. See, in the class 400 to 500, upper limit is 500. So the next class is started with 500. Okay, so there is an order or there is a specified arrangements or upper limit of a class is same as the lower limit of the next class. So this type of data or this type of class intervals are known as continuous data or continuous class interval. So first we need to identify or verify whether the given class intervals are continuous class intervals or not. Okay. If the given data is in the form of continuous form, then we can directly draw the graph. Otherwise means suppose the given data is not in the form of continuous form. First we need to convert the data into continuous class intervals, then draw the graph. That is the method. Okay. See this table. The first column length and second column number of leaves. Listen the first column only. Here the class intervals are 118 to 126, 127 to 135, 136 to 144 and so on. See here the first interval is 118 to 126. At the same time next interval starting with 127. Okay, 127 to 135. Next class is starting with 136. So the given class intervals are now not in the form of continuous class intervals form. I hope it's clear to you. Okay, there is no orderly arrangements because upper limit of the first class is not same as the lower limit of the next class. So in this case we can say that the given class intervals are discontinuous. So we need to convert this data, discontinuous data into continuous data. So the method is that we are subtracting 0.5 from the lower limit and adding 0.5 to the upper limit. Okay, 0.5 subtracted from lower limit and add 0.5 to the upper limit. Now see the table. See, before the first class interval was 118 to 126. Here we did 0.5 subtracted from the lower limit and 0.5 add to the upper limit. So 118 minus 0.5 becomes 117.5. 126 plus 0.5 becomes 126.5. And before the second class interval was 127. So from here we subtract 0.5. So 127 minus 0.5 implies 126.5. And we add 0.5 to 135, became 135.5. Now look at the first and second class intervals. 117.5 to 126.5. See, the next class started with 126.5 to 135.5. Now listen, upper limit of the first class, that is 126.5, is same as the lower limit of the next class. Okay, so we can see there is a orderly arrangements in these limits. Similarly, we can continue the same procedure to the next class limits also. Okay, so now we can see that the given or converted class intervals is in the form of continuous data. So whatever data given in the question, first you have to verify whether the data is continuous or not. If it is continuous, once again remind you, you can directly go to the method of drawing the graph. Otherwise, you have to convert the data into continuous data, then make the graph. This is the method. Anyway, in the next class, we will discuss how to draw bar graph as well as histogram using the given data. Go through the concept and also attend the test paper. Thank you all.